Alright, let's move on to another concept of limits, the infinite limits. Usually infinite limits, we usually using this concept to finding the vertical asymptotes. This concept applies to find the vertical asymptotes of a function, right, of a graph. So for example, if I have a function to be 1 over x, okay, this is the most simple reciprocal function, right? So I'm going to explain why. So you have to understand that the limit of one-sided limit from the previous video, right? So what happened when you have a number 0 from the right, okay, 0 from the right. So as you know that, let's say, for example, I'm taking a number divided by 0.1. Okay, 1. This is the graph of fx equals to 1 over x, right? So then, what if the number is 1 divided by 0.1? You know you are getting a number 10, right? A small number, when you divide a number by a small number, you are getting a bigger number, right? So, what happens when you divide by 0.01? So you're getting 100. What happens when you divide it by 0.00001? What can you observe? That the number you are getting 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, right? So you are getting bigger and bigger. The smaller the number on the denominator, this is a constant, it doesn't change, right? This is unknown, it's changed. So when you're getting a number smaller and smaller, this one we're getting bigger and bigger. So if you divide by a number that are very, very small, for example, this is just an example for you, alright? If a number that very small, but it's not 0, we said, these cases here, we said that the x is approaching 0 from the right. Approaching 0, but not 0. Because 0 plus means very near to 0, but it's a positive number, right? So it's still bigger than 0. This number is still bigger than 0, right? 001, right? This is a number, it's not 0. So, but it's approaching from the right. Yes or not? So, the number we're getting bigger, right? Very big. The smaller the number on the denominator, the bigger the number. We can say that this number is approaching positive infinity. Right? You see all the value here is positive, right? This one may be 1 trillion. Okay? So then you know that. So how about if I said that, so means this number here is actually getting a very big number. A very big number. We don't know what is that number. Undefined, right? We don't know. We don't know what is it. We don't know. So means positive infinity. Right? Very big number. So what happened when you approaching the number from the left, right? So this is a concept, right? Hope you are not boring when you listen to this concept. It's a very important concept, right? So this concept here will tell you what happened to the graph. So now you can see that 0 minus, right? 0 approaching 0 from the left. So it means that from the left, to the right of 0 is a positive number. To the left of 0 is a negative number, right? So what happened when fx equals to 1 over x? When you divide by negative 0.1, right? It's from the left to the left of 0. So you are getting negative 10. So 1 over negative 0.01, you getting negative 100. So 1 over negative 0.00001, you're getting negative, right? So you have 100,000, right? You see the number getting bigger and bigger when this thing is getting nearer to 0, right? But it's from the left. It's a negative number, right? Negative from the left. So when you divide by a number that are very, very small, so I just telling you this example because I want you to understand the meaning of approaching from the left and from the right. So it's very, very small. I don't know how small is it. So but I definitely know the smaller the number, the nearer the number to 0, the greater the negative value, right? It's approaching negative infinity. So we say that the limit of 0 from the left, approaching from the left, you are getting negative infinity. So this is the case where the limit as x approaching 0 does not exist. Does not exist. Okay, then I show you that as I know that you understand, you know the shape of the graph, right? You understand the shape of this graph. Every student very familiar about the shape of this graph, but a few students, not many students understand the property of this graph by using limits here. So this is the place where x equals to 0, right? So x approaching 0 from the left. From the left, the graph will be, okay, if I draw, the graph supposed to be this way. As you memorized before, the shape of the graph will be looking like this way, right? It will approaching, right? Approaching, so they were going this way. So they were approaching and going to negative infinity. It's going to negative infinity, a very big negative number. So you see that 0 minus, when you're going to the 0 from the left, you are getting negative infinity, going down. So when you look at 0 plus from the right, means that from the right near to 0, this is the meaning that go to 0 from the right, go to 0 from the right, go to 0 from the right, the graph will be going higher and higher, positive infinity. Can you see that? So just now through the example, you can see that the graph was getting higher and higher, right? So this type of line, the point x equals to 0, the point x equal to 0 is named as the vertical asymptote. The vertical asymptotes. Okay, sorry, the vertical asymptote, because vertically the graph will be approaching to infinity, either positive or negative infinity, right? So this is a vertical asymptote. So from here, this is the infinite limits. Infinite limits. So means as the denominator approaching to 0, the number getting bigger, either it's positive or negative. Okay, I will give you another example so that you have better understanding. Alright, let's consider this example here. Alright, let's consider this example. So this is a case. We have a case here. So if you think detail, what is meant by 2 plus, right? 2 plus. 2 plus. 2 plus means when you set x approaching 2 from the right, means that the number for x is around 2.00000000. Wow, they are very near to 2, but it's not 2. Okay, for example, okay, this is lebih kurang, okay, lebih kurang. It can be even smaller, alright, even smaller. So, so what happened when is x approaching to 2 minus, right? 2 minus, so x is around very small, 2, right? 2 from the right, 2 plus, from the left, 2 minus. It's like near to 2, but it's not 2 yet. So it's 1.99999. Very small. Okay? Very small. So, what is the meaning here, right? So what happened? Now we consider, because this is a number, right? This is a number. There is a value here, a positive number here. Okay, a positive number. So this is also a positive number. So we have to consider, right? We have to consider what happened to the denominator here. So when you put this case, this is number, and you put substitute 2. When you substitute 2, 5. You substitute 2. 2 minus 2 getting 0. A number divided by 0, undefined. Right? It's undefined. So it's undefined. So means that it's like you are getting undefined here, can be infinity. Can be infinity. So then you look at here. How about 2 minus x? What happened? 2 minus x will happen what? What will happen? So means that 2 minus x we're getting, as you think that when the value of x approaching 2 from the right, so the value of x is like 2.0001. 2 minus a number, try to imagine Imagine in your mind. So 2 minus 2.00000001. For example, this number is still bigger than this number. So when you minus this 2, you are getting a number negative, right? Negative 0.0 whatever lah. So 2 minus a number slightly, then you know that you are getting a negative small number, a very small negative number. Okay, it's a small negative number. So a very small negative number here. Okay, a very small negative number. So negative number. So when you're getting a very small negative number for this one, right? 2 minus x, a very small, but it's negative, right? It's negative. This one will be a positive. 5 is positive. So you know that this thing will be negative. Because positive, negative, negative, right? Negative. So you were getting infinity. You are getting infinity. What's the reason? Because a number divided by, for example, 5. 5 divided by this one. Which is, you know that approaching from the right, it will be getting negative 0.00000001. Right? So you see that you divide by a very small number. Just now from the explanation from the previous example, you are getting a very positive, negative, negative. The number become very big, right? Negative infinity, right? So that's the meaning here. So later I will teach you a shortcut to understand this. So but now this is a concept, right? This is a concept, the actual concept. So later I will teach you a shortcut to understand this one, to find the value even faster. All right. So now for this case here, same thing also, but from the left, the value of x is like 1.9999. What happened when from the left? What is the value for this? So 2 minus x. So for example, minus 1.999999, because x approaching 2 minus, right? So you're getting a number like positive. It's a positive number, right? 1. It's a positive number, but very near to 0, right? 2 minus, this number is smaller than 2. So you're getting a number, for example, you take 5 divide by the 2 minus x here is referred to this one now. 2 minus x now. It's a very small positive number. You are getting a positive infinity, right? So you are getting positive infinity for this case here, right? As you see that, this is called infinite limits, where the limits going to infinity, right? Infinity, it can be negative, it can be positive here. So from my observation here, when you near to 2, you have getting an infinity, or you from the left you're getting infinity. So I can say that x equals to 2 is a vertical asymptote. This is the way we verify asymptote. It's asymptote. So okay, from here I can sketch the graph and let you see what is the meaning of this graph here. Alright, let's look at the meanings of the vertical asymptote here. So I just sketch for you. So the graph for y and x means you, from your knowledge of the sketching graph, you know that 2, because y2 is an asymptote. For example, if I have a function fx to be 5 over 2 minus x, as you know that in the rational function, the denominator should not be 0, so x should not be 2, right? So 2 will be your asymptote. You know that, last time you know that, this one, oh, this one is your asymptote. But you don't know what happened to the asymptote, right? Why this is your asymptote? You know that x cannot be 2. Then you know that 2 is your asymptote. But you don't know what is the meaning of asymptote here. So from here you see, 2 from the right. 2 from the right. From the right. Right? From the right. From the left. Right? Nearer to 2. 2.001. Very near to 2. So the graph will be going negative infinity. Means that the graph will be going this way. It will going negative infinity. Going down. You see? As you near to 2, the graph is going down. Can you see that? This one and this one. This point I'm moving, I show a motion here. So you see, I get very near, very near to 2, and near to negative infinity. So how about from the left, right? From the left. So from the left, this graph moving from the left, so the graph will be going down or going up. We look at positive infinity, right? Positive from the left. From the left, so the graph have to going up. The nearer to 2, okay, the nearer to 2 from the left, so the graph will be going up to positive infinity. All right, positive. This is the meaning. That's why this is your asymptote. This is your vertical asymptotes here. So this is the meaning of infinite limits. All right, in this video, for the concept, just now the concept that, and this concept here, I just introduced you about the meaning of infinite limits. Means that the number, there is a number on top, right? There is a value on top, but when you substitute the 2 into the denominator, you're getting 0. This is the case here. It's not 0 over 0, it's a number over 0. It's undefined. So for this type of cases, we were getting a vertical asymptotes. So because the limit, we were getting infinity. So when you see that the limits, there is a value, and you direct substitute, you're getting a 0, it must be infinity. Just we need to identify whether they are negative or positive. Alright, so the next video, I'm going to introduce you another way of evaluate this type of limits in a very easy way. Alright.